Now that we completed the toolbox, assembled it, now let's start machining the box so we can actually bend it and build it. First thing we want to do is make sure that we go to our add-ins and to see that if MasterCam for SolidWorks is loaded. Mine is on the startup, so every time I start it up, it activates the sim and I can go into SolidWorks. You can also just turn it on for the one session as well. I'm going to choose OK. I'm going to open up a recent document, and it will be the base. Now that the base is open, let's go ahead and get it set up for MasterCam. First thing I want to do is make a second configuration of the part. So I'm going to come up here to the tabs and create a new configuration. We're going to add a configuration. The configuration will be machining, toolbox, base. Description, MasterCam for SolidWorks. We'll choose that. And it says copy the data from the active configuration to the configuration machine toolbox. Yes. Apply this choice to all configurations. No. The appearance for the material is different than the existing appearance. Would you like to link the display states configuration to show the material appearance in each configuration? Yes, I would like the material to be the same. Let's go back over to the feature manner design tree. And now we're going to flatten this out. By flattening this out, we're not affecting the assembly because we're using this configuration. So that's why I did that. So let's go here and get to the top plane. And remember, when we drew this in the top plane of SolidWorks. It is not the top plane of MasterCam, so we need to do a little setup for this. So we're going to actually activate the tab of MasterCam Toolpath Manager. We're going to expand the properties, and we're going to start at File, and we're going to replace the default post with, say, a Haas 3-axis post. So I'll choose the Haas inch post. And we'll choose, the next thing we'll do is tool settings. We'll give it a program number 1, 2, 3, 4. We're going to assign the tools sequentially, and we can call it number 1, but this gives it number 1 whether it's in our turret or not, so it sets us up. We're going to select the type of materials, the mill library, and we're going to choose 50/50 series. Then the next one, we're going to go to stock setup. The stock setup for the Y is going to be 9.625. The X will be 12 inches, and the Y will be 1/16 of an inch. I'm going to keep my origin at the center and choose display. And we're going to hit OK. This is important to watch what happens here. As we're in the top, you can see it's laid out as such. Remember, when we drew this, this is MasterCam's top and not SolidWorks. To set it up, we need to go back to our stock setup, our stock plane, and set up for MasterCam front to match what we're doing with SolidWorks. We'll choose OK, and now you can see it's laid out, but our axes are known as not the correct layout. The next step we want to do is go to Plane Manager, and we want to use geometry to set this up. So I'm going to use the face. I'm going to use the face of this to set up my origin. And you can see my X and my Y is laid out, and it's at the top of the part where I want it. I can name this plane and call it Tool Box Plane. Hit OK, and make it active. The tool, the WC, is active to that. So now when I hit this, I can look at it from the top, and my axes are correctly laid out. We can look again back here at stock setup. I chose the front, this information, and now if I want to, I can also come in here and choose the plane that I want, and it'll give me my coordinates as well. So now I'm relating my plane manager, my stock setup, all to that same information. Now let's get ready to machine this. We'll put it in isometric. we can see this a lot easier. We see our axes are correct. My X is going this way, my Y is this way, and my Z's this way. Very important, the layout of how we have it here must lay out on our machine, and our machine must be capable of cutting this size of a part. Let's get started to machine. We're just going to use a basic 2D contour to complete the toolbox. I'm going to come over here and I'm going to choose just the face choice. I'll choose my face. It picks up all the edge curves, as you can see, of the part by just touching one face. It gives me all the change in the chain tab. I can see each one is selected. I'll fit it to screen. There we go. And you can see each one is active. Go back up to the top. And the only thing I can see really wrong with this is that this one, the outside geometry, is actually going the wrong direction. I want to flip it. So I can come down here and use this flip arrow to flip the direction. As well, I can choose these forward and reverse points to set up where I want to start from. So I can start there. I can pull it all the way around and keep going forward and start there. I can also look at, say, I don't want to cut out the profile first. I want to cut out the holes first, so I can take that number one that it picked up as number one and move it into position where I would like it. So I'll move it all the way down. And as you can see, the first toolpath would be that circle. The second one would be that. Third one will be that. And it's kind of looking a little bit out of order when you actually go through the chains. So I can be more proactive in making my toolpath more efficient by choosing where I want to. So if I'm ending up here, I want to end up my last circle here, then machine to there. So I want to start there. So I want to find that one to be number one. So as we go through, we want to find, there it is, number one. I will move that to number one. And then number two would be that one there. So I need to move that into space two. Then that one should be moved down once. That one there, that one there. Now we want to get to this one here, should be after two, which that one we know can move down. That would be probably at the bottom. That one will be right after 7. And then this one needs to move down 1. And if we look at it now, we should have it organized. First toolpath, second toolpath, third toolpath, fourth toolpath, 5, 6, 7, 8, and then profile. Not a lot of movement there, but it worked great. I'll hit check. Tool, we'll call it the toolbox base. It's based off this name. The type of toolpath we're going to use is contour. The tool, we're going to come down here and choose tool. We're going to select from library. We're going to choose filter so you'll understand how this works. We're going to choose none, and what we're looking for are end mills. And so I'm going to choose the end mill. Now I can also use tool diameters if I want to say equal to, less than, equal than, or greater than, excuse me, or between. So if I wanted to say, let's say something that's less than 0.25, I just want to look at anything that's under a quarter inch, it will show me anything below that. And the tool I'm choosing is a 5/32. I'll choose OK. It appears as tool number 1. And now I would like to change some of its information because the tool we're using is called an O flute. So I'm going to right button mouse click on the tool, edit the tool. The information here, the cutting length seems very accurate. It's the finalize that I want to do because I know it's only a 1 flute. I can calculate that. I can also know that I can only go 6,000 RPMs based off the machine we're going to be using. A chip load of 3,000 will be fine. And it gives me a feed rate of 18 inches, which is perfect to what I want. The material of the tool is actually a carbide. And we can give it an additive name here. We could call it an O flute. And we can choose finish. And you can see it updated it here. It updated my feeds and speeds. I'm going to activate rapid retract. The next step I want to do is choose my cut parameters. Everything sets fine in here. We don't have to use any depth of cut because it's only a 1/16 of an inch and this tool is capable of cutting through in one shot. Lead in, lead out though, I like to change and I like to choose not at midpoints or close contours at midpoints. I would like to change this 50 thou, give it a little bit of distance, a ramp in, and the radius, I'm going to drop it down to 25%, and then I will copy this back over to that side. Not real difficult. We're going to add a breakthrough. A breakthrough allows the tool to go through into our wasteboard about 20 thou, 30 thou would be better. And then the absolute depth, since I touched the top, it's giving me where it's at. I'll put in 0.0625. That's the thickness of the material to go through, plus the 30 thousandths. So when you really look at it, what we're going through is about 925 thousandths of an inch, but we're cutting on a wasteboard. Our feed plane doesn't have to be so close, so far away. We could put 0.1 and an absolute retract. So if the top of our stock or material is 0, we're actually, anytime we move from hole to hole, we will move a 1/4 inch above the part. Very simple. We won't turn on coolant. This is a no flute. Air will be just fine. And we can see that there is a tool path that went around. You can see how nice it is. When it finishes up here, here's the last tool path. You can see the ramp just plunging in, not wasting plunge, and then ramps in and goes around. And so we can actually see this in solid form. Now that we're done applying the tool path, we can actually see this in a solid machinable form by using MasterCam's verifying toolpath here. So we're going to verify the selected toolpath. It will activate MasterCam's verification. And now we can see it ready for machining. We can turn up the precision if we like, depending on how much strength, and we can turn down the speed to take a look about how it would come out. There's our holes falling in production mode. Quick movement there, goes around the part, and we have just completed how we wanted to see MasterCam cutting inside SolidWorks, an easy project. The next step is to get it to the bender and bend it into shape and start building our box. Before we do that, I just want you to know that there's other information in here. You can see the view. You can see it in multiple views. A lot of people don't get a chance to use this. 4 views. You can see all views going through. You can also go back to home while it's there, and you can turn the stock on translucent so you can see through it. We'll rewind it. It's solid. And you can actually see, if I take one of these and zoom in on it, you'll actually see the tool go through and cut translucent. You can see the pieces in there. And then as it cuts around, you'll see it go all the way around. That's a neat thing to see. A lot of people don't take advantage of these other views and look at them, but I like them. I like to sometimes turn off the tool completely. I like to rewind it and see it just cut the part out without the tool. As times I like the tool on, but I don't like the holder on, so I'll click tool components and turn that off and just launch the tool itself. So you'll learn how to mess with this and change it around and manipulate it the way you would like to see it and based off the strength of your computer. So I'll close this down. And the last step we'll do is actually get it ready to G1 it, create the NC code, create the name of it. We'll put that on the desktop. And that would be the toolbox information here. And I will save that. And it's creating our NC code, which contains our G&M codes, our tool information too as well. And here it comes. And now if we can set up the machine, this information will cut out the base. Good luck.